I just can't find the perfect pair of jeans. Hi, I'm Meilyn Ward, and today I'm going to be teaching you how to make the best pair of DIY jeans. But first, let me show you how I used to do it. I used a specific restriction enzyme, in this case PSD1, to cut the jeans. Already we're encountering the first problem. Once I release the restriction enzyme, it cuts at all of these restriction sites. I can't pick and choose. Plus, I wanted to cut the jeans here, but I didn't use the correct restriction enzyme. Restriction sites are specific to each restriction enzyme, so I cut all the previous fragments with PST1, but EcoR1 will cut at different locations. This also means that gene fragments cut with different restriction enzymes can't stick together. Only 2 gene fragments cut with the same restriction enzyme can join easily. Let's take a look at the actual DNA. Pieces cut with the same restriction enzyme stick together perfectly because most restriction enzymes cut the strands unevenly. This quality, called sticky ends, is another reason why fragments cut with different restriction enzymes can't connect. As you can see, this strategy works. It's fine if you just want to make sure a fragment from one set of genes ends up somewhere within another. But a more specific method would allow for so many more possibilities. What you're going to need are clustered, regularly interspaced short palindromic repeats. And me, clustered, regularly interspaced short palindromic repeats associated protein number 9. But since we're cool, you can call us CRISPR and Cas9. CRISPR is a universal restriction enzyme, meaning it can cut anywhere as long as the Cas9 leads it to the right segment. In addition, CRISPR leaves blunt ends, meaning that the fragments can also stick wherever. Scientists have to make sure to modify the Cas9 though, so it knows to which segment it should lead the CRISPR enzyme. This is done by specially crafting a piece of RNA that can bind to or hybridize with the exact portion of DNA in question. Then the DNA fragments are introduced to each other. If you wait enough time, they'll probably hydrogen bond on their own. But just to make it permanent, DNA ligase, or DNA glue, needs to generate the tiny missing pieces of phosphate sugar backbone wherever the genes meet. Now you've got yourself some recombinant genes! Currently, this process is being implemented into more and more fields, including gene therapy, a type of treatment that involves replacing or adding on to defective genes in patients with genetic disorders like sickle cell anemia. With CRISPR-Cas9, you can make more resilient crops, cures to diseases previously thought fatal, and a cool new pair of jeans!